Okay, so what we're going to do now is we're going to construct and prove our construction of an equilateral triangle. So it's key that we also prove that what we've constructed is an equilateral triangle. So what you do here is I'm going to give you some segment, and I'm going to say construct an equilateral triangle with segment length AB. So what you do here is you open up your compass to the length of AB, and you go from point A and you draw a circle of radius AB. So that's going to look something like this. This is not me using a compass, so your construction should be perfect. Mine will not be. Okay? So you draw this circle. You could go all the way around, but it's not necessary. You draw half the circle, the semicircle, and that should be sufficient. And again, you should convince yourself that from A to any point on this circle, right? If I say that this is point C, this length is the same as the length AB, and you could already maybe tell that AC in my picture is not the same as AB, but in yours it should be. So again, we should convince ourselves that from A to any point on this first circle, whatever, this length is the same as this length. These two lengths are congruent, we say, okay? Now, that was from A, and then you drew the circle with its center at A. You just essentially do the same thing, but now at point B. So you go and you open up your compass, and again, it should be the length from A to B, and you draw the circle that's centered at B, okay, that has a radius of AB. Now, every single point, again, from B to this point C is going to be the same as the length from A to B, right? So as long as we have this in our minds, we can now see that what we've done here is that this point right here, let's call it C, and then this point down here, let's call it C prime. Okay, we say that C prime, that either of these things will be an equilateral triangle. This one here and the other one down there will be an equilateral triangle. Let's prove that triangle ABC is an equilateral triangle. Well, is AC, is this length from A to B the same as the length from A to C? Yes. Okay, these two lengths must be the same in the triangle. Now, is it true that the length from A to B is the same as the length from A to C? Yes, that's also true, right? That must be true, that this length is the same as this one, and then, of course, these two are the same. AC is the same as BC, and this is indeed an equilateral triangle. Let's see if we could write a statements and reasons and see if this makes any sense whatsoever. So 1, right? You want to start writing what's given by your construction. So it should be clear to you that the distance from A to C is that the distance from A to B. Yes, so I'm going to say AB is congruent to AC. And we're going to say by our construction, right? We're going to list a whole bunch of things by our construction. Okay, it's just evident when we say by our construction. And then we're going to say, well, and you should convince yourself, why is that true? Well, because you drew this circle, right? You drew this circle, this first circle, okay? And this first circle, right, the distance from the center to the edge is always the same. AC from A to B is going to be the same length. So this is true by your construction. Similarly, right, you should convince yourself that from B to C is the same thing as from B to A. So I'm going to say that BC is congruent to AB, right? And again, by your construction. Really, we should then just convince ourselves that the distance from A to B is the same as the distance, as all three of these lengths are the same, right? And do I have that here? Yeah, I do, because I could just say 2 is going to say AB is the same as AC, BC is the same as AB, so then what do I know? BC is the same thing as AC by transitivity. Okay, you should see that this is transitive. And now I really have 3 things, right? I have that, or let's convince ourselves why this is transitive. Let's slow down. So AC is the same thing as AB, and AB is the same thing as BC, therefore AC is the same thing as BC. There we go. Okay, good. Yeah, I have it. So I could go from AC to AB, and then I can go from AB to BC, therefore I can go from AC to BC, and that's transitive. And then 3 is that triangle ABC is equilateral. And that's because it's definition of equilateral triangle, or you could say all 3 sides congruent. And you're done. It's a simple idea, but just know how to construct an equilateral triangle, and then this is a general idea behind a proof of the equilateral triangle. What we need to say, just to go over, we should convince ourselves of just a further statement, just a different statement. So we did this is done. But while we're here, this is done. While we're here, we should convince ourselves that all the angles are congruent in an equilateral triangle. So I don't know anything about these angles, not yet. But now let's just go and further say that we know, because of the isosceles triangle theorem, we know that if 2 sides of a triangle are congruent, then the corresponding angles are congruent. So here I have it where this side is congruent to this side, therefore this angle is congruent to this angle. And I could run through a similar argument, but now using this side and this side, right? So if I split it this way, so then that means this one will be congruent to this one, and then that shows that all 3 sides, all 3 angles are indeed congruent. You just apply isosceles triangle theorem twice. So we should just say, if equilateral, if all the sides are congruent, if equilateral triangle, then all angles congruent. And you just sort of use isosceles triangle theorem twice. If this side is congruent to this side, then the corresponding sides are congruent. So then that means that this angle is congruent to this angle. And then you could just say, okay, well, now look at the triangle. These 2 sides are also congruent, right? This side and this side, right? So then their corresponding angles are congruent. So this angle is then congruent to this angle, and then that forces all 3 to be congruent. So just have this in our minds for our next proof, because we need to do a construction and proof of something else that relies on this fact, that if it's an equilateral triangle, then all angles are congruent.